You see the title, I would like to refer to the background image you see here. Actually, it tells the whole story. We simply have to interpret it. You see all the big high mountains in southern Central Asia, Eastern Asia, and it's quite obvious and it's quite clear that these mountains have a great importance for the water supply of this whole continent. And it's also quite clear that it's differentiated between the more arid areas, which are showing up in this light tone here, where actually irrigation is predominant, and that means that economy, population, and so on totally depends on these water resources. Whereas in these areas here, which are much more dark, we have mainly rain-fed agriculture. Nevertheless, most of these big rivers originating from the Central Asian high mountains also, of course, traverse these forelands here. I've managed this. I would like to speak about present four aspects. Very shortly, what I just said here, maybe a little bit in a more focused way, the South Asia's water towers. Then, as an introduction to understand why the discussion today is so much focused on these areas, I shortly present the Indus Plain as the world's largest irrigation network. And then the question, too much water, too little water, that's a very famous title. There are books written exactly with this title, and it's really something which is of high political relevance. And finally, and there I might use a little bit more time, or maybe the focus will be put on this here, what just has been mentioned before, that of course there is a lot of research now going on in these areas, and actually we are just developing Upper Indus River Basin program, which is internationally concentrated, and about this I would like to say a few more words. Now, have a close look up to the western part, Indus, and you will realize I will mainly speak about now this Pakistani context, where we have the western Himalayas, the Karakorum, and the eastern part of the Hindukush. And it's quite obvious, and you can outline here quite easily that we have within a rather arid environment, quite obviously a line of different landscape type. It's all irrigated area here, actually ranging from the mountains down to the Arabian Sea. The Indus River as the main river in this area, that's quite important, as its source or its origin actually in the Himalayan area itself. Not in the front range, it's between the western Himalaya and then the central Himalaya, and here Karakorum and so on. It originates in the Kailash area, which is actually the main spring area for Brahmaputra, Indus, Ganges, and other rivers in this area. And it's quite clear, that's in a very simple way expressed, that these mountains really serve as water towers. You can see, and just these two figures, that in the case of Pakistan, 80% of the agricultural area is irrigated, that this area here as indicated, and 90% of the agricultural production is actually, or comes out of these areas here. So the rest, 10%, is mainly in the foothills of the mountains or within the mountain ranges. Having a look at the high mountain systems, I simply would like to show 2-3 slides which somehow illustrate this situation. In the central Karakorum, which we are looking towards the east, K2 would be somewhere up here. We have huge glaciers, and high up area which is elevated in these regions here. These snow fields are between 5,000 or up to 5,500. Many of the peaks are ranging or reaching 8,000 meters above sea level. We have many very extended glacier systems coming down into the valleys. For instance, here a very strange structure, I will come back to this, surging glacier which moves from these high plateaus down into the valleys. A similar structure you can see here. Or here from another Google Earth view, the setting in the central mountains of the landscape. You can see again these high mountains with K2, the second highest mountain in the world. Snow covers in the upper parts, then all in all rather arid land, valleys, and the green areas here are actually the irrigated areas in the valley bottoms. These are all irrigated fields because most of the slopes and also the valleys almost don't get any rainfall. They are arid and they totally depend on the runoff of these meltwater tributaries. And once more, irrigation is almost the only way to have some kind of production down there. Say and that the irrigated fields don't or are not fed by these rivers here, but from the side valleys, from melting water from the glaciers, because simply it was simply not possible to lift up the water to these plains here. And on the other hand, it's not possible really to settle in the valleys. So they are settlements and so on are all a little bit lifted above. When you go further down, you follow then the Indus River, that's the Indus River here, through deep gorges where the river turns from these western direction to the southern direction, cuts through the Hindukush area here through Khoistan, and it's a deeply incised situation here. You always can see, or already can see, that we have some vegetation on the slopes. You can guess there are some forests. That means the more you come to the front ranges, the more you are exposed to the monsoonal systems, which are, of course, then on the south slope totally dominating. So we have very, very distinct gradients of humidity from south to north, but also from the lowlands to the highlands. And this will be one of the issues we have to discuss. Show once the waters have left the mountains, you get huge plains, you get a huge river system which slowly moves down to the Arabian Sea and which actually feeds all these irrigated oases we have seen at the very beginning. Now let's have a short look to the Indus Plain as it said, the world's largest irrigation network. Here once more you have a map of this whole system. It's superimposed again on a satellite image. Now you can see that the Indus has its source actually in an area which nowadays is China, it belongs to China. Then we have an Indian portion, finally a Pakistani, and from the western side also Afghanistan and an Afghan contribution through Kabul River here. So Indus River is the main river here, but we have many contributing tributaries, Jhelum, Chenab, Ravi, Beas, Satluj. I think from school time you know all these names. But all in all, they feed the Indus system. Or was that wrong? You don't remember. Anyway, in a very schematic outline, you can see once more how it looks like. The Indus, then the different tributary rivers, mainly from nowadays Indian part here. And there is one question, and which actually is the main question of the country's economy and policy management and so on. how to manage these resources, these river water resources for domestic use, for irrigation, for energy production. Because it's quite clear, these rivers, of course, flow along their riverbeds, and the plains outside have somehow to be reached by technical means. And how it really looks like, that's a graph which I got from WAPDA, Water and Energy Production Agency, and it shows a system how in the early 20th century up to now engineers managed to reach actually the whole area, the whole flat land. There are two or three different structures which I don't go into the details, simply would like to mention. You see, these are main channels which actually serve to divert the waters from the western rivers into the eastern rivers here, in order to feed them and to get enough water in these areas here. Sometimes vice versa, but that's the main idea, to feed these river systems here. The second thing is, you see, well, this is actually possible through the erection and construction of barrage. These are not real big dams, but just barrage across these rivers. They enable to let water through, but also to divert water. And then, of course, you have a huge number, and these are just a few here, secondary channels which then feed the agricultural areas, a whole system from actually the foothills down to the Arabian Sea. What is also shown here is this line, which is nowadays an international boundary between India in the eastern part here and Pakistan here. And this is, I mean, I'm sure you know about these things as well. That was one of the real difficult issues after partition, when after the Second World War, when the Indian subcontinent became independent. This was one of the critical issues. Who is actually controlling these water systems here? Again, I don't go into the details. I simply can refer to a set of international and national treaties. They are, that's a continuing discussion and a lot of cheating, a lot of diplomatic crisis, one has to say. During some of the wars between India and Pakistan, India immediately tried to stop or divert the waters. It was a weapon in this context. At the same time, and that is now a problem which science is a little bit suffering, because this is such a critical issue between the countries, data on the runoff are somehow kept secret. There is not a free exchange of data. Sometimes they are manipulated, because it's quite clear, if you say, for instance, 50% of a certain amount of water has to be released to the neighboring country, it very much depends. What is 100%? So it's quite understandable that there is a real big discussion. At the same time, there are problems that the infrastructure of this system is very much suffering. It's partially outdated and very costly to repair it, to extend it, to maintain it, and to optimize it. There's a big discussion on, you know, the big landlords who have access to it, small farmers who are at the tail ends of these channels, who are very often not anymore fed with water and are really suffering. It's a big fight within the Pakistani society on this, and also international loans very much are linked to find new ways to have a fair distribution of this water. The consequences of these regulations between the countries you can see on this slide here, also from Google Earth. That is the national boundary between India on this side, Pakistan on this side. It's just a small section, of course, which clearly indicates, obviously, here we have other rights of access to these channels here, whereas in this case, India had to, or is in a shortage, it's rather south here. So you can see, if you interpret satellite pictures quite clearly, where obviously a rather guaranteed access to these waters is still possible, and where obviously some contracts or so create problems. Now, one of the discussions which is really, I think, again and again, also in the international discussion, visible: too much water, too little water. And I simply would like to remind that now almost 3 years ago, this huge Indus flood, what was in all our media discussed, and it was considered as to be one of the biggest catastrophes related to runoff of rivers of too much water in this case. It's an event which it started in the high mountains. It goes to one of the cities up there, and you get an impression about the power of the water which came down there. And it was not just one flood. There were 3 floods within a few weeks. All had to be linked to a very specific atmospheric circulation. Those who are a little bit familiar with climatology maybe remember that exactly at the same time, this was July 2007, in August, it repeated the same, more or less the same. In Russia, there were huge forest fires, extreme drought, and it goes back to a circulation pattern, Rossby wave, which was very stable for weeks, which is actually exceptional. And it was considered, is this linked to what we say climate change, or what has it to do? Anyway, the situation in the highlands was dramatic and very, very destructive. It destroyed infrastructure. If you go, or if you, those days in the lowlands, you can see this comparison. It's near Sukur, that's somewhere in the central part of the Indus River in the plains. That's how it looks during normal conditions, weather conditions. You see the Indus coming down here. There are contributing rivers here. There are channels diverted. That's one of these barrages, and so on. When the flood came, all this was more or less covered. And the result that was Oxfam Australia has finally mapped the results of this flood, which was still in September. It's indicated here like this. The blue areas are the flooded areas which were still underwater in September. That means months after this whole thing has happened. And then with these colors, the affected districts. Nevertheless, some 20 million people, all in all, have been affected. That's 10% or even more of the total population of Pakistan has been heavily affected, and infrastructure was damaged, and almost a total loss of the harvest, which created hunger problems and initiated international help. Now, that was too much water. But in the long run, and that is no question, water scarcity will be the real problem. And the question is, water scarcity, that means less water. Now, what does it mean, less water? Is it less water in the rivers, maybe due to climate change? Or is it water which is less available to people? And there is one thing, and that is really, really, I would say, a frightening perspective. Looking at the demographic development, you can see that just shortly after independence, Pakistan had below 50 million inhabitants, actually 38 million in 1947. Now it has reached some 50 or say 60 years later roughly 200 million. It will rise up in the next, now almost 40 years, up to 350 to 500 million people. That's a real dramatic situation because it reduces the availability of water, of course, dramatically. And it's quite clear already now, but certainly in a very near future, water will be the limiting factor. That's no question. Simply because of the number, but we have to know also the way of using water has changed. We have industry, we have growing living standards in the urban areas. That means the amount per capita of water is, the need for it has increased. And in addition, water quality is a very, very big problem. The quality is rapidly going down. Salination is a problem, but also pollution, which is absolutely dramatic. We shouldn't make too strong recommendations on this. Our rivers were very dirty as well. It took maybe decades somehow to clean it. Pakistan at the moment is still in a position where the water quality rapidly goes down. So for me it's absolutely clear that this whole situation will be of highest relevance. And it's quite clear, and this has meanwhile increased, that all in all we have in the last years a slight reduction of the overall availability of water, but we have zero flow into the Arabian Sea. That means we have a number of years now where no water anymore reaches the Arabian Sea. That means also that the tail-end farmers in this system simply didn't get any more water for irrigation. That's a real difficult situation. The other point is, you can see what it means. If the Indus doesn't reach any more the Arabian Sea, or simply in a reduced amount, now the tidal movements, the daily tidal movements have a little bit more free space into it. And what can be observed is what is indicated with the red arrows here. The salination of the groundwater, the penetration of the of salted, salinated groundwater into the agricultural area is rapidly increasing and going forward. That means here we have a reduction of usable land, and the same actually happens also here because there's not enough water for irrigation. Evaporation means salination of the surface. So, in this context now, in this situation where everybody says water becomes our problem, in 2007, IPCC, Intergovernmental Panel of Climate Change, made their very, very famous forecast, 2035, and that's now wording from the report. Glaciers in the Himalaya are receding faster than in any other part of the world. The likelihood of them disappearing by the year 2035 and perhaps sooner is very high. I just come back to this because it has been corrected afterwards. But that was really an announcement which was shocking for this area. They said, we have such big problems, now this add to the problems and how to solve it. Anyway, it was very clear, and it is still clear, I have to say, it's not solved. There is really action needed. The first point is quite clear. The efficiency of the irrigation system has to be improved. Upgrading of the infrastructure. After the floods, many of these barrages, of these channels have been destroyed. They must be repaired, they must be upgraded, their efficiency must be upgraded. Second point, Pakistan became a cotton exporting country. Cotton is quite a water consuming crop, and even wheat exporting it sometimes towards Afghanistan or so. It became quite clear there must be ways, there must be efforts to introduce more crop varieties which need less water. Desalination of soils. The groundwater management is something which is very, very important, because in addition to the general irrigation, groundwater retrieving or pumps and things like this are very much functioning, and it means that again there's a big difference between the availability of water in the Punjab compared to Sindh or here in the western part, Balochistan. Here in this area they have sometimes too much water, and they use it for, of course, for many purposes. There is a lot of evaporation as well, whereas in this area it should be increased, the runoff, in order to wash out also the salt in the grounds. That means we have a big differences in salination of the soils between the upper part and the lower part here. So this can somehow be regulated by the management of the runoff here. Then increased storage capacities, big dams, small dams in the mountain areas to store water up there. I just will come back to this in a minute. And then, of course, what is discussed, you can read it every day in the media in Pakistan, a new water economy, which includes water rights, defined shares for agriculture, how much can be used for urban, for industrial use, energy production, what has to be remained or left unused due to ecological reasons, and so on. And then, of course, in this context, the transboundary management of the water, that means Indian, but also in the higher areas, China has been included, of Afghanistan in the west, a revision of the bilateral treaties. And then, of course, this is only possible if you have enough reliable institutions in the country, if the empowerment of the institutions is. Just to show 2-3 slides on the dams. There was evidence, and that started in the British times, to build storage capacities just at the outlet of the rivers out of the mountains, in order to have the surplus of water immediately after melting snow times or melting glaciers, to store it here and slowly distribute it when it's needed, but also to produce energy. Now, there's one problem, because these waters which feed all these dams, but also the lowlands, which originates in the mountains, they have a lot of the suspended load from glacial melting runoffs and so on is very, very high. We have seen it on the pictures before, rather arid slopes in the mountains, very steep slopes when you reach Khoistan, and the surface erosion is quite intensive. So suspended load is very significant, and it's already 10 years back, or even more than 10 years back, that it became very obvious that this Tarbela, and it's not the only one, but Tarbela will be covered rather soon, or filled with sediments rather soon. And you see here it's a cross section, that's the dam on this side, and it goes valley up here, and this was the maximum operational level of the lake. That was the original surface, ground surface of the lake, and meanwhile we have huge masses of sediments in the lake, and it's very clear, and it's predicted that within some maybe 30 years it will be more or less full. Anyway, there are plans now to go Indus upward and to build a series of new big dams in all different purposes, of course. Storage for water, quite clear. Energy production, quite clear. But also to hold back the sediments in the mountain itself. And I just got a very nice slide from a colleague, Professor Hauptmann from Heidelberg, from the academies there. It shows, it's eastward looking, that's Indus, well it flows like this. That is this oasis Skardu here, quite a big irrigation. That is Baltistan, Shigar and so on. Again you see all these oases in here, and the idea is to have a dam on this side and flooding this whole area here. And this is now nicely made. You see this will all be flooded. So you can imagine there's a big discussion between the lowlands, which say, hey, we have big needs, we need water, we need energy, there are mountains far away, remote, steep, snowy, nobody lives there, and so on, so we make big lakes. And of course, people living here in these areas, and by the way, the very famous Karakorum Highway actually touches these areas as well, linked to China. It's a strategic road, you know. They say, please, forget about this. We cannot accept it, even if you reimburse us and give some compensation somewhere in the lowlands. A slide also from this research group in Heidelberg. There are tens of thousands of rock carvings from the Buddhist time, 2nd to 5th century, sometimes to 7th century, which are part of the cultural heritage of this area. They would be flooded, they would disappear under sediments and so on. So it's a big discussion on this as well. Now let's come back to IPC, what I just said before. That was their statement, how it was published. Quite soon after this publication, IPCC rejected it due to an international contradiction on the scientific side, which said it's impossible, that's not realistic. So IPCC declared it was a mistake, we take it back. But, of course, the question is now, if not in 2035, what does happen? What would be a more reliable statement? Are they disappearing or not? And when, if yes, when? And if not, why not? And I would say that's now a little bit cynical what I wrote here. I would say it was quite a lucky erroneous statement for research, because it was quite clear. Research was now under pressure. It was asked, please find out what happens here. What are the forecasts? In the Karakorum has reduced, or is dramatically reduced. There were phases where it advanced, when it went back, and so on. There's dynamic in it. But today, nowadays, it has dramatically reduced. At the same time, you find, and I showed it before, a number of glaciers which do exactly the opposite, which are advancing, like this glacier here, and you see the dimensions. These are 10 kilometers, so maybe 25 kilometers of length, and this glacier is advancing. So the question, what happens? Is it an anomaly here, or is it typical, or what's behind it? The same happens here. There are a number of glaciers. Now, the question is, what are the consequences for the people there? You can see there is a, well, one has to explain it. This is an irrigated oasis, as we have seen before. These in this area are also, it's not so clearly visible, irrigated areas. And when you consider the question where the water comes from, you can clearly see that those oases which are fed by the runoff, the main runoff of the glacier, they are still rather secure. This glacier is melting away, but it provides water. For how long, that's another question. Those higher located irrigated fields which were fed from the side moraines, runoff from these side moraines and fed these channels, fed the areas here. Now once the glacier is reducing, these channels are not anymore, they don't reach anymore the runoff or the melting glaciers. That means, on a small scale, this fact that many of the glaciers are reducing has consequences within the mountain systems as well. It's plus minus a decision. Those can live quite easily, those have to leave their country or their fields. Another question which finally should be focused now in the research. Question is, one, if the glaciers would disappear, what would be the reduction of the runoff of Indus? And you can see these are rather recent publications. Imberseel, who is his a Dutch colleague, produced one paper after the other. He calculated there would be a minor reduction of the overall runoff of Indus if the glaciers would not be here anymore. We still have annual seasonal snow covers and so on. World Bank, in their forecast, had a much more dramatic figure. And so on. All in all, to make it simple, a big uncertainty in all these statements. Now, an international group of scientists somehow sat together and tried to define what should be the questions we have to study. And I quickly go through, it's quite clear. Just what I have mentioned before. What are the contributions? And what is the input in this hydrologic system? Rainfall, snow, how is the evaporation in these arid mountain areas? What are the gradients, horizontal, vertical gradients of these different variables? And it's quite clear that there are no automatic weather stations, or just a few. It should be established a special network of automatic weather stations. Then the question we just have discussed before, contribution of these. What's the dynamics of the seasonal snow cover? It's like in our mountains there is an annual variation of it. The type of glaciers, I will show you just one example afterwards. There are many different types of glaciers, debris covered, not covered at all, avalanche-fed, wind-blown fed glaciers, and so on. The dynamics, especially the question, where do we have surging glaciers? Rather new, that was not even a central topic in the IPCC report, is the impact of black carbon. It's very obvious, and those who are familiar with the area, or those who have a chance to fly over it, the atmospheric pollution from the lowlands is dramatic. It's really an absolutely dramatic situation by industrial processes, but also by burning forests, burning harvest rests and so on. So there's a huge, and Beijing these days gives you an example, impact of black carbon on the glaciers, changing their albedo and so on. Then the question, of course, is that nowadays, these days, you can do a lot with remote sensing, mapping the seasonal snow cover. You use physical models. There are very sophisticated mass balance model for glaciers nowadays available. But one of the problems is there are only little in situ measurements. And there may be also for geographers, where we come from, might be a chance to work as well in this area. Sorry, it's quite clear that IPCC makes available a set of scenarios, and it's quite clear, once we have understood these things, we should apply them on the IPCC scenarios. And after all, the inclusion of proxy data showing a long-term distribution development is very basic. It's quite clear that you can set up some kind of a conceptual model like this, showing, the mountain, glacier here, debris covered, debris free. You have a seasonal snow cover. In winter it's down here, in summer it's up here, fluctuating. And finally the question is, which portion of this dynamics contributes to the runoff out here? Glacial runoff, by melting glacier, nibal runoff by the seasonally melting snow cover, pluvial runoff by rainfall events. One should add permafrost, which is changing now, and so on. And this, of course, all in all is steered or controlled by a number of processes, atmospheric processes, I said drifting snow avalanches, how much is the total rainfall, how much is evaporation, impact of black carbon, and all this should be somehow understood and put into this. Now I simply give you one example which we update continuously. Most of the models rely on some input data. And simply the question of precipitation, which is a basic or one of the basic inputs, shows how different values are actually applied to produce such a runoff which only occasionally is measured. So it's an extremely hypothetical situation. Why do we have such a big difference? Why is these differences? It's very simple. Most of the stations are, of course, located where you have a village or a settlement. They are in the valleys. The valleys are dry. And this situation is not extrapolatable into the total area. There are literally no stations in high altitudes. So, just again to show you this example of the Batura Glacier. Nowadays, say maybe well, now, meanwhile, 5 to 7 years ago, it started that the research groups came in. And I simply would like to say you the confusion of the situation. You see figures. Our program on this glacier started in '95, and these are some climatic stations here, ranging between roughly 2,000 meters up to 4,000 meters. We have a runoff station here, installed to measure the runoff glacier. Then the Chinese came in 2010. These are the red climatic stations. The result is also that you have totally different installation types. Up here on the top left is one of our stations. So different methods, different places, duplication and so on. It's a question of organization on an international level, which is very, very difficult. Now, let me come back to this small model here. You can see the basic equations, and then, sorry, it's in reality much more complex, I know, but you know, the runoff somehow is defined by atmospheric and cryospheric variables, precipitation, evaporation, change in storage. I don't go into the details. Nevertheless, we tried to establish some kind of a vertical rainfall distribution, or I have to say it in another way, which altitudinal belt contributes to the runoff by melting snow, melting glaciers, and so on. And we came to the conclusion that has been published already several years ago, that somewhere we have very little input in the low altitudes, which perfectly is in line with what Met Department measures and so on. Then we have an increase going up maybe to an area around 5,000 meters, and from there upwards the contribution of specific runoff is reduced again. So we have a very specific vertical gradient. Interestingly enough, Ken Hewitt, one of the long-term researchers up there, came to a rather similar conclusion, but based on totally different observations. He made snow pits, you know, digging holes into the snow cover, defining the amount of precipitable water which is contained in it, but all in all came to a rather similar altitudinal distribution. Now, since we have installed now runoff stations, which were really missing in this area, especially on one of the glaciers we are observing now for 3 years, we have runoff data. If we go back, there was one British group working in the 90s, and in the context of the construction of Karakorum Highway, where Batura Glacier destroyed the highway by pushing forward, the Chinese have also made runoff measurements. And you can see, well, I don't go into the details now. Obviously, there was some more runoff in these times. We measured a little bit less. Maybe it's a methodological problem, I don't know. Anyway, if we calculate back what would be the average input of rainfall, and if we assume that the evaporation that's mentioned up there is in the range of 200 millimeters, we must get much, much more rainfall compared to what is available up to now. You see, these are calculated figures which are double, 3, 4 times higher than what is available up to now. So the question is, what's going on? We see melting glaciers, we see surging glaciers, we have totally different input data for rainfall based on the runoff data. Somehow we must have obviously a vertical different processes here. Growing conditions in the higher altitudes, reducing conditions in the lower. It could make sense if we have, and that's observed, slightly increased temperatures. Also the amount of water vapor in the atmosphere is increased. That means we might, even if you have high temperature, we might have quite significantly more snowfall in the higher areas where nobody has proper observations. Now we calculated new gradients. Again, I don't go into the details. Gradient, it's a little bit too linear, I know. But obviously, the potential rainfall increases very much with the high altitudes, maybe even 3,000 millimeters per year, which is absolutely out of the range of what has been measured. Now, and I soon approach the end, don't worry. There's just in the last year, few articles have been published, mainly in Nature Geoscience or in Nature and Science, based on totally new, well, based on another approach. They used laser satellite sensors, which provide you very accurate altitudinal information. And they compared, in this case it was a comparison of 2 data sets from 2000 and 2008, so 8 years in between, by a group, Gardel from Grenoble and colleagues. And they came to this conclusion for the central and western Karakorum. Here you have the altitude from 3,000 to 6,500 meters, and on this scale you have the difference between the scenes 2000 and 2008 in altitude. So it's the change between these two. And what's interesting is that if you look on these lines here, that in the lower parts we obviously have a reduction of the surface elevation, whereas in higher altitude we have positive values. It's growing up there, which supports what I just suggested before. Then the second point, which is indicated here, with these lines going up, down, or this one here, like this, where you have within a few years a very dramatic increase of mass up to more than 100 meters as the elevation of the glacier grown. And just before it was reduced. These are typical surging glaciers which move very rapidly down and in a wave which is propagating. So all in all, the conclusion that in the high altitudes we obviously have another type of mass balance compared to the lower parts, I think somehow becomes being proved. Now again, a group, CAB, originally from the ETH Zurich, now in Bergen, Oslo, they made it for the whole of the Himalaya and they came to a very interesting conclusion. The same methodology, on a very rough, very generalized way. They could show, and this is indicated with the colors up there. You see the red one is a reduction of ice and snow masses, surface reduction by almost 1 meter per year. Is it lowering? Whereas in the blue area down there, it's growing. And it comes clearly out that we have a regional differentiation. The Karakorum up there, where we actually at the moment have our main research area, is growing. It's the so-called Karakorum anomaly, whereas the majority of all glaciers are in fact disappearing or reducing, not disappearing, but very much reducing. It's quite clear. The answer, we are in the monsoon sea course, the natural fluctuations now superimposed by human impacts. The other curves I leave apart. For me, and that's now the consensus in this program, it's quite clear. We have only a chance to understand what's going on and also to make reliable, say, scenarios if we combine the different scales. If we combine global, regional scale information, which is mainly satellite data, up there, general atmospheric input, then the topography, general glacier models, and so on. If we combine this global data sets with the regional ones, finally, regional really focused on individual cases to understand what's going on, where we need, of course, again, the higher resolution topographical control. We have to have very adapted local glacier models. We need precise meteorological input data. We need proxy data, what I just showed before. And again, we must combine it. And we have to focus, that's what is mentioned here, on vertical gradients, which are up to now still very unknown. And this is only possible if we include field studies and something which is completely missing. Whatever publication you read, whatever data sets you get from Met Department, it's never said how accurate actually these data are. I'm more and more careful with the data we get for our studies. Second last picture. This now becomes, as I said, a real issue, first on individual research groups. Now it becomes an issue which is internationally coordinated. And there's a quite clear consensus, and mainly coordinated by ICIMOD, the International Center of Integrated Mountain Development, which covers this whole area. We should focus on case studies. Indus is one, Kailash, Kosi, Myanmar on this, with Brahmaputra, Salween, where we have to define what are the problems, what are the methods we would like to apply so that we can compare what is outcoming, and it's quite clear. This relates to international programs which are already for many, many years going on. Also, not the details, all these mountain areas with a different significance in terms of runoff for their forelands somehow are nowadays confronted with these problems. With this, I would like to close my contribution. It shows, maybe as a last image, the importance of vertical gradients. Climatic stations are usually down in the desert of the Indus Valley in this case, whereas the water resources in the case of Nanga Parbat are high up and not known yet. So, thanks a lot for your attention.